Alright, Subcourse 5096, Edition A, Direct Pipeline Operations, Army Institute Professional Development, Army Correspondence Course Program. Lesson 1, Monitoring Tank Cleaning, Vapor Frame Cleaning, Storage Tanks. Introduction. Tank cleaning is a task that should not be approached lightly, as there has been many hazards involved in this process. The hazards lead to lead, hydrogen sulfide, explosive vapors just mentioned. If you find just in position to supervise cleaning and storage tanks, you must be thoroughly familiar with these hazards. Part A, designing, using, a petroleum storage tank. The following factors must be considered when using and designing, using petroleum storage tanks. Loss results, filling of the breathing of the seepage. Filling is loss. Atmospheric storage tank is filled with the vapor above the product will be forced out of the tank with the result of the loss of the product. Breathing loss. The atmospheric storage tank using the static storage with loss of the product of the vapor forced out of the tank due to the expansion product as it heats up during the day. Conversely, product cools and contracts. The air will be drawn in sleep. It's lost due to small ruptures in the tank. Security against fire hazards. Escaping vapor and vapors being heavier than air will tend to seek through low spots. Will be present with the hazardous conditions, particularly dangerous during the filling operation. Leaks are always hazard must be corrected as soon as they observe real estate. The proximity of the storage tanks to be in other facilities must be taken into consideration when surviving potential hazards. Firewalk, dikes, berms must be constructed in order to minimize some of the risks involved with bulk petroleum storage and distribution. Part B, types of tanks. Keeping in mind of the problems we have discussed, let us discuss the various types of tanks according with the job that they will do, so that they can employ them with the best of the solve the problem. Fix the roof of the tank's bolted steel cone roof. This is the type extensively in the military. Comes with the various issues. Sizes is classified as semi-permanent. It can be moved. The tank cannot withstand pressure of more than 1 to 3 ounces per cubic inch of the vacuum, and no more than 1/2 ounce of the cubic inch. For this reason, the tanks have 3 vents and have high vapor loss of the welded steel cone. The type of the tank is most commonly used with the tank of the permanent installation because of the construction risk. As skilled personnel, the type of the tank will withstand the pressure from 3 to 8 ounces cubic inches. Vacuuming 1.5 ounces per cubic inch is equipped with the pressure vacuum vents. The reason for the welded cone roof tank is better suited for the storage of the high voltage products within bolted steel tank. Floating roof tanks. The floating roof tank is on the surface of the product that virtually eliminates breathing and filling loss. The 3 types of floating roofs we'll discuss are pan type, a large type of floating tank slightly smaller than diameter. The tank shell system of flexible shoes closes the space between the edge of the roof and the tank shell. A pontoon systems closed in compartments of the pontoons to increase the floating stability, simplifies the structure. A double deck, 2 separate decks of entirely back surfaces are provided with the insulation from the sun rays and cut down the loss of the product of evaporation. All tanks of the floating roofs have a wind girder around the top of the edge of the to stiffen the shell when the roof is down. Many commercial firms, the Air Force base employs the tanks. The gasoline JP4 must be best adapted where tanks are filled with the type, but frequently they are somewhat of the maintenance problem because of the sealing material used between the tank shell and the roof. Cone roof with a floating pan. The floating roof represents a problem with the cold climates because of the accumulation of ice snow. Because of the problem, floating roof tanks can be modified with the fixed roof installed with the procedure employed with the advantages of the fixed roof and floating roofs. Underground tanks. Construction underground tanks are coated with the coal tar coating to prevent corrosion. This may be the concrete supporting well around the exterior surface of the vapor loss. Underground tanks are also commonly equipped with the deep wall pumps and the pressure vacuum vents. Because of the stabilized temperature mid-50s, underground storage tanks have very little vapor loss. Leakages underground storage are very hard to detect and may show up at the water tables after the leak has occurred. Cut-in covers are constructed with the scoping of the out of the holes. Expression is in the earth. The seating of the steel storage tank of the covering in the earth, so the only part of the structure above the ground would be the small shack of the manhole with the vent to permit the access of the tank to allow the excessive vapors to escape. Part C, pressure vacuum vent. The pressure vacuum vent is an automatic device designed to reduce the evaporation loss to help relieve excessive pressure of the vacuum builds up during operation. As a result of that, atmospheric temperature variation of the vent consists of the pressure section, vacuum section. Each section, according with a predetermined setting, to ensure the efficient operation should be inspected monthly. Flame arresters are used to prevent flashbacks in the tank and cause fire. The flame arrestor is usually placed in between the roof of the one type of the flame arrestor consists of the tie of the coil fine wire mesh closed with a heavy casing with a flange roof.
Good night. I'm going to lay down in my room.
Alright, manometers help with the roof. The floating roof tanks to facilitate the gauging. They are used to measure the difference between the level of the product, the tank level of the product, and the gauging well subsequently at the aggregate gauge. The gauge has self-explanatory individuals involved with the gauges that should be careful not to drop articles down the gauging hatches so much as the bad effect of the product also might block the valve, the damage to the pump, the panhole, the clean out of the door opening designed to permit entry for such a purpose as cleaning of the tank and the making of the repairs. Grounding the stem of the tanks are inherent with the ground. They conduct contact with the ground, and ground wires are not required. Determining needed. Visual inspection. The inspection of the interior with the tank of the manway opening with any other suitable means without the actual physical entry into the tank. Physical entry and inspection. The inspection of the interior tank of the physical entry is required special preparations according to the existing safety regulation, changing of the product and services, contaminated product, any type of the major repairs and maintenance schedule, cleaning in accordance with Military Handbook 200. General procedure selection purpose only of the component with the personnel should be selected with the tank cleaning medical certification, and personnel should be cleared with the medics to ensure that they are physically fit to work with the hazard involved with the training program. All personnel should be required to attend the training on the hazard involved with any of the special hazards pertaining to the tank, particular tank job assignments. Job assignments should be controlled with the supervisor to prevent the personnel from exposure to the hazard. Preparation area of the surrounding the tank should be inspected for the low pace of the vapors could collect. Any fire hazards such as the electrical equipment, hot work, and open flames. Entrance of the area. The entrance of the area should be posted with the warning signs guards to keep the unauthorized personnel from entering the area. The tank should be inspected for the type of the amount of sludge to be removed. The type of the amount of the equipment required will depend on the condition of the tank and the amount of sludge. To remove emergency first aid should be available in the immediate area. Vacuum truck. Safety set of the safety set which will include such items such as fresh air masks, boots, gloves, and hard hats. Showers, washing facilities will be available for all personnel firefighting equipment. Party empty blanking off of the tank of the lines and vapor freeing with blanking off of the tank lines before the tank is opened. All the products should be pumped out and pumped or drained to the lowest point. In situation where the contractor is cleaning the tank, a statement should be written stating a product recovered from the property of the U.S. government. Blanking off at the accomplished with the first closing of all the valves near the tank, the breaking of the connection, placing the blinds in all the lines, and then cleaning out the door then is removed, allowing the access to the interior of the tank. Vapor freeing. The several means of vapor freeing tanks, however, the best method is one because of the environmental consideration most commonly used with the forced ventilation, mechanical ventilation, electrical fans are used. The method, all wiring connection must be vapor-proof. Natural ventilation, the top of the tank open is also allowed to circulate through the tank until all the vapor is required. Steam ventilation. Steam is one of the most effective methods of vapor freeing tanks because of their size and not effective for the large diameter tanks. The steam is effective on tanker truck and railway cars. During the vapor freeing storage of the operation, have a well-trained man tested the vapor, the variety of the instrument, or use to check the vapors. Explosive meters used to indicate the concentration as the percent of the lower the combustible limit now is present in the vapor of the volume. A reading of 100% of the explosive meter means that the tank atmosphere is 100% of the explosive of the vapor concentration with at least 1% of the volume is present. The tank being ready for the cleaning that has been contained with lead product, then the tester may enter the tank with the respiratory equipment. Readings of an explosive meter showing less than 100% of the lower limit inside the vapor reading should be taken out 1 foot above the sludge. If the tank has not been does not contain lead, if it is safe, enter with the respiratory equipment with the readings are between 0% and 4% of the lower limit. Hydrogen sulfide detector. Hydrogen sulfide detector consists of the suction bulb with a glass tube detector, a frame with a scale to use the detector, break off the ends of the glass detector tube. The reading on the scale is shown on the percent of the oxygen detector is similar to the explosive meter. In some cases, they are a combination. Part F, hazards. There are many hazards involved with the tank cleaning personnel. Many of the understand hazards for the cleaning starts with tetraethyl lead in the tank that has been using the stored lead with the gasoline is hazardous throughout cleaning of the process. Even though the tank has been vapor-freed, respiratory equipment, protective clothing may be worn with all times. The lead affects the central nervous system and can cause permanent brain damage in the event of death. In order for the tank to be declared lead-free, it must be sandblasted to clean the bright metal, certified with the safety engineer. Hydrogen sulfide rarely found with the finish with the product may be found with the tank's held crude products and Navy special fuel oil and heating the oils of the fuel's high sulfur content in the combustible range between 1.3 and 46% by volume. The toxic limit is 20 parts per million, and this is far below with the petroleum vapor. The presence of the hydrogen sulfide can be detected as a rotten egg odor. Fuel vapors are narcotic. Inhaling the vapors slow nervous system to the point where the breathing is stopped. In addition, with inhaling all small events with the vapors, they irritate the lungs and respiratory system. Lack of oxygen normally contains 21% oxygen concentration less than 7% and is dangerous. Fuel vapors, in addition with being narcotic, displace oxygen in the tank regardless of the type of the safety equipment to use. It must be approved with the Bureau of the Mine Safety. The kit considers the respiratory fresh air mask, rubber boots and steel toes, white coveralls, lifelines, harness, air hose, hard hats, rubber gloves, and safety should be inspected and cleaned before and after each use. Part G, general tank cleaning procedure. Before water pumping is beneath the tank, cleaning out of the door to receive the flow of sludge. There are a number of commercial cleaners that use to clean inside of the tank. The cleaners emulsify with the sludge and film with the floor and the sidewall for the tank. The solution allowed to remain on the floor of the walls are recommended a period of time. This wall and the floor in the tank hose down with a high pressure water and the emulsion and flush out of the door of the sump. The common method used to finish the cleaning up of the sweep, Aipd and squeegee of the sludge out of the door. Part H, disposal of the sludge. Strict state and federal environmental programs make it imperative that all personnel be aware of the pertinent laws of the disposal action is taken. Leaded sludge is disposed of the high-intensity heat. Unleaded sludge may be disposed of aeration, landside, hillsides, burning at a high-intensity heat. However, there are any method used must be approved by the Environmental Protection Agency. All trucks used to transport the sludge must be approved by the state and federal agency. A certified issue for each of the vehicle. The disposal site must also be approved by the EPA, and it was as with any operation of the petroleum oil lubrication storage distribution is extremely important for the personnel familiar with the procedure guidelines methodology outlined in Field Manual 2400, Military Environmental Protection TC 204001, Soldier Environmental, all the other publications related to the environmental protection. Lesson 2. Alright. Lesson 2, Inland Petroleum Distribution System. Introduction. Since the day of World War II, petroleum NCOs have grappled with the challenges of moving all the fuel from the front lines of the battle quickly and efficiently. Today, the NCOs now have the advantage over the predecessor because the accomplice attack of the Army Inland Petroleum Distribution System. Inland Petroleum Distribution System is the Army's primary method of receiving, storing, distribution bulk of the fuel. To support military fuels, military forces deployed in worldwide contingency operations system consists of both commercial military equipment and made up of three systems. The tactical petroleum terminal and pipeline components for the pump station successfully integrated with these elements. The troops can move from any source found in the theater of operation. The Inland Petroleum Distribution System is designed for the lightweight, rapidly deployed pipeline terminal system that can be used with developed theaters of the operation interface with the existing host nation forces, such as a refinery with the Navy Offshore Petroleum Discharge System, OPDS. The Navy is responsible for the delivery of the petroleum for the offshore tank with a high water mark of the system. Is modular in design and can be tailored with any locality operation. This shows a stack of pipes. Pipeline is constructed with a 5-mile piping set that are 2,779 by 9.5 foot in sections. Each 5-mile set of 10 sections with each of the pump station. They are constant wall thickness of 0.404 inches that can be cut to length and required regroove with the cutting of the grooving of the tool furnish. They are used with the closed short gaps of the pipeline. Each section has a black line down with the length of the easy identification for the nipple material. Major components: 5-mile pipeline set, valves, elbow, suppliers container 1 of the 13, couple clamps and nipplers container 2 of 13, coupling clamps container 3 of 4 of 13, and pipe containers 5 through 13, 13 of 13, pipe connection assembly, switch manifold container 1 of 5, contaminated fuel module container 2 of 5, fire suppression equipment container 3 of 5, transfer hose line tricon container 4 of 5, PLA PLCA support assembly container 505. Pipeline support equipment 600-gallon pump with the spare parts container 105 for the cutting of the groove machines container 205 for the pipe and nipples 3 and 5 Pioneer tool kits and valve the container 405. Gap crossing sandbags containers 505. Recovery equipment pumps tools equipment container 1 of 5. Safety supply forms container 2 of 3. Cleaning compounds of the container 3 of 3. Suspension bridge with 100 foot pipeline suspension bridge 200 foot pipeline suspension bridge 400 foot pipeline suspension bridge. Base tower anchors container 1 of 2. Cables and supplies container 2 of 2. Pumping station. Each pumping station has 2 skid mounted diesel engine driven with the 3 stage conventional Figo mainline pumps with the operational output of 800 gallons per minute at 1,800 feet of the head of the 2,100 RPMs only, as operated at the time of the launcher. Receives assembly of the dual line strainer assembly located on the incoming side of the station. Floodlight set are also components of the pump station, except for the mainline pumps. All pump station equipment will be stored in 4 20-foot ISO containers. More detailed descriptions, illustration of the pump station equipment can be found with the Field Manual 1067-1, Concepts of Equipment of the Petroleum Operation, Chapter 7 of the Pipeline Pumping Station. Launcher and receiver assembly container 1 of 6. Valve fittings container 2 of 6. Flood set and spare parts container 3 of 6. Strainer and auxiliary fuel system container 4 of 6. 800-gallon mainline pump the container 5 of 6. 800-gallon per minute mainline pumps container 6 of 6. It shows a gallon pump station, pipeline pump station. Tactical Petroleum Terminal. The mission of the Tactical Petroleum Terminal is to receive, store, dispense liquid, specifically GPA and motor gasoline, aviation jet fuel. Figure that is served at the base terminal and undeveloped theater. It can be used to develop theater and supplemental existing facilities that are inadequate and damage. The Tactical Petroleum Terminal it was designed to operate a maximum allowable operating pressure of the 150 psi. The standard Tactical Petroleum Terminal has a storage capacity of 3,700,000 gallons and 5,000 barrels. Collapsible fabric tanks. The Tactical Petroleum Terminal is moored modular with 3 identical fuel units, and each Tactical Petroleum Terminal also has 1 pipeline connection. The total Tactical Petroleum Terminal is stored at 77 ISO containers. The fuel unit consists of 3 tank farm assembly with the 2 5,000 barrel fabric tanks. Each of the tank truck receipt manifold with the fuel dispensing assembly, transfer hose line assembly, 6 fire suppression assemblies, 5 50,000 gallon optional tank configuration of fuel unit and support assembly as total of 24 ISO containers used to store 1 fuel minimum of 1,600 feet between the units. Tanker farm assembly consisted of 2 5,000 barrels per 5,000 barrels fabric tanks, hose line pump, the associated with the hose and valves fitting of the total of 3 containers for each of the assembly, at least 400 feet between the assemblies. 5,000 barrel tank accessory container 1 of 24. 5,000 barrel tank accessory container 2 of 24. 600 gallon pump with the 6-inch hose of container 3 of 24. 5,000 barrel tank accessory container 4 of 24. 5,000 barrel tank accessory container 5 of 24. 600 gallon per minute and 6-inch hose of the container 6 of 24. 5,000 barrel tank accessory 7 of 24. 5,000 barrel tank accessory container 8 of 24. 600 gallon per minute with a pump line and 6-inch hose container 9 of 24. Tanker truck receipt manifold consists of the hose line pump associated with equipment provided with the 4 defueling station. This is used to receive the fuel from the fuel tanker trucks into the containers. Hose valves, the fittings container 16 and 24. 600 gallon pump container 17 and 24. Fuel dispensing assembly disseminating fuel for the directly use of the bulk fuel transportation of 5,000 gallon collapsible drum of the 6 station of the trucks and the 2 drums of 1 container of the container of 19 and 24. Transfer hose line assembly is used to connect with the tanker farms assembly, switching the manifold fuel dispensing assembly of the tanker truck received with the manifold operation of the tactical terminal petroleum terminal. There are 4 transfer hose line assemblies in a tactical petroleum terminal, 1 in each of the fuel unit, 1 in the pipeline connection assembly. Each of the assembly has 500 feet by 6 inches and a hose line packed in 3 tricons, 5 hoses before tricon to be major components in the total system. 1 ISO container equivalency container 1824. Fire suppression assembly, the main component with the wheel mounted with the fire extinguisher mounted with the 2 wheels. The trailer with the system is designed to apply with the dry chemical purple K until the fire is in control. They are applied with the aqueous film foaming form or AFFF, creating with a blanket effect with the chemical show and continue to be applied with the AFFF until the solution is exhausted, until there's no existing smolder pockets remaining that could cause reignition. One container for each of the 6 assembly containers of the 10 through 15 24 5,000 gallon tank option consists of 2 50,000 gallon tanks, collapsible fabric tanks, 1 transfer pump of 350 gallon pumps, 1 350 gallon pump. Fills are separated with the option given to the commander with additional 100,000 gallons of storage space to be used in the situation dictates the total option stored with 1 container, container 20 of 24. The fuel unit support assembly consists of the fuel unit interim support in item system or ISIL. 2 viewed floodlight unit sets, 1 displacement evacuation system, 1 hose line suspension system kit, 2 hose line installation repair kit, spare hose line pump, 600 gallon per minute, 4 containers of storage assembly, 600 gallon per pumps, a container 21 24, floodlight sets 24 44. Hose line fitting container 23 to 24, and spare parts and supplies 24 and 24. The floodlight set with the trailer mounted is designed to hold all the components for the engine generator. So includes the 6.0 kilowatts for the 2-cylinder 4-cycle air-cooled diesel engine with 4 pullable brushes. Receive fuel engine with external voltage regulation. It has 18-gallon fuel tank with a wide mouth fill cup, starting with the power supply with the 12-volt 4D size battery, telescoping tower assembly with extended and disabled the gusty winds of about up to 40 miles per hour. Portal to tripod mast are stable with wind width to 15 miles per hour. The displace of the evacuation is used to remove the fuel, evacuate the small residual quantity of the fuel vapor and any other air within the loss. They consist of the displacement and the injector displacing fluid of the ball with the ball receiver and end caps that seal off the hose line and air ejector used to evacuate residual fuel and vapor from the hose line. Suspension bridge prefabricated with the vacuum kits 100, 200, 400 feet with the foot sizes. They are provided with the crossing river, the chasm, ravines, identify the central areas of operation, the major components for the tower, guy wires, the deadpan, anchors, main cables, suspenders, cross barriers, and staggering boards, tension cables, wind guys, and hand rope. This shows a tactical petroleum terminal outlay. Pipeline connection assembly. The pipeline connection assembly is the fuel received from the inside of the or issued to the pipeline. The total assembly is stored in the 4 containers with the 3 tricons. This manifold allows the tactical petroleum terminal to be connected with the pipeline controls of the flow in and out within the tactical petroleum container terminal. 1 container contaminated with the fuel model consists of the 2 50,000 gallon collapsible fabric tanks used to hold the contaminated fuel bending or disposal of the transfer pump. The loaded tanker trucks. 1 container with the fire suppression assembly main component with 1 container. Pipeline connection support assembly contains additional ISIL 1 aviation petroleum test kit with the hose line suspension kit, 1 displacement evacuation kit, 2 hose line installation and repair kits, 1 container. Special assemblies are available. They aid the total system construction interface. The beach interface is an assembly adapters connected with the IPDS and OPDS. It also accesses to the pipeline for the shore base for the forces, for example, U.S. Marines. The pipeline support equipment is the basis of the allocation of 1 set of the pipeline support equipment of the period of the 100 pipeline to be installed with the assembly construction. Contains this item required to assist the construction and operation of the pipeline. The pipeline support equipment will accompany each of the deployed pipeline segment. 5 containers equipment include the 2 wheel-mounted hose line pumps of 600 gallons per minute with the using source of the pumps in the pipeline received the forms fuel of the commercial storage, 2 cutting of the grooving machines, cutting in the pipeline pumping station, nipple to 4 hydraulic drive heads for the anchors installation, 2 tapping machine for the tapping into the pipeline in or draining of the portion of the line usually needed when required to repair a leak. The dead weight tester used to calibrate the gauges, 5 additional elbow sets, toolkit with pump alignment tools, additional 9.5 foot pipe sections. Part B, quality surveillance. Quality surveillance includes the procedure used to operate of the tactical petroleum terminal to ensure the petroleum product received, stored, and dispensed for the inland petroleum dispensing system meet to the minimum specification when delivered. To use the quality control of the inspection performed with the refinery personnel to monitor the production of particular petroleum product with the quality assurance of the Army program to determine the refinery other source that fulfills the contract concerning the quantity and the quality of the petroleum product. The quality assurance is complete when the product is accepted by the Army. It becomes the Army owned. The quality assurance, the QS quality surveillance consists of the measurement taken with the ensure the petroleum product which have been accepted with the Army are still required with the quality delivered to the user. The quality surveillance is responsible for the organization having physical possession of the Army owned product. Sample points. The high pressure for the sampling assembly installed with the pipeline 1/2 of the 1 mile of the upstream with the tactical petroleum. The terminal of the assembly is used at the spot. The interface approach with the tactical petroleum. The terminal of the advanced warning is arrival of the low pressure fuel sample assembly is installed with the header of the feeding of the tactical petroleum terminal. Switching manifold with the pipeline with the primary use of the fuel sampling assembly to check incoming fuel and establish the and or the last interface between the batches. Difference of the specification and can be used at the spot. Sample and check the quality incoming into the draw sample laboratory testing. The water detector kit adapter is the discharge for each of the filters separated with the primary purpose to check the quality to make sure no water is carried over the dispensing assembly. Samples from the adapter using the aviation fuel tank fuel contamination testing kit are taken downstream. Each of the filters separated to ensure the filters separated performantly properly with the customer qualified with the quality fuel that meets the specifications and test once every 4 hours. The operation dispensing assembly perform 3 checks at the 15-minute intervals after filter separation is first put into operation or whenever the elements are changed. Part C is pipeline construction. Pipeline installation. Aluminum pipeline is used in an inland petroleum dispensing system. Solidly susceptible and heat change the temperature area causes the pipe to expand and to contract. The tendency to require the pipeline installation to follow with certain rules, especially exactly the pipeline must be installed at the straight and level and possible as desired turns and change of the direction must be made with the using elbows vertical as well as horizontal direction. Anchors use the direction expansion and contraction of the pipeline to expansion and contraction of devices. Aluminum pipe is subject to thermal expansion that can overstress couplings and cause breaks in the pipeline. Since the pipeline will install with above ground, the pipeline will move and expand with the contract for the temperature variation. Some geographical locations where the pipeline may be used, the temperature can vary with as much as 100 degrees Fahrenheit in 24 hours, which can cause the expansion up to 20 inches of the 50 sections pipe. Expansion can cause the pipeline to fail at a coupling if the side pressure deflects the joint more than 40 degrees. The expansion must be controlled with the directed spots specifically designed to move with the pipeline expansion and contraction. Contraction, expansion, and contraction. Controlling expansion and contraction. To control the expected expansion, and contraction movement, the pipeline must be equipped with the anchor's expansion device. The anchor fixes the pipeline to the ground directs the expansion towards the expansion device. The flexes coupling into the elbows allows the device to move without breaking the integrity of the pipeline. In a desert environmental where the temperature changes anywhere to 50 to 100 degrees, there may be a maximum 50 section of pipe between the expansion contraction device which anchor and between the more temperature environmental space. The temperature change and a loss of 50 degrees. The distance between expansion and contraction devices can be extended with a 100 section of the pipe. This still must be anchored between the device and the pipeline must be laid in the anchor of the explosion devices. Anchor sequence of anchors is just joint outside of each of the pump stations starting the sequence expansion loops on the hills should be no more than 15 sections of pipe downhill from an anchor. There are 2 types of expansion devices used within the inland petroleum dispensing system, the U-shaped loop and the Z-shaped offset. Both devices require the pipeline flexibility and considered equal from the standpoint. The Z-shaped offset should be used insufficient. It is sufficiently clearly traced the width of 30 feet available. If the trace is not available, the U-shaped loop should be installed with a cleared area of the 30 feet by 30 feet as required for the U-loop. The U-shaped loop would normally be constructed with a pipeline of 19 feet on the side of the may be used of 45 to 90 degree elbows in combination thereof. As an elbow limited to the 90 degree elbow should be used whenever possible. The deflection of the loop can be used much as 20 inches for the cold. For the hot position, Z-shaped offset will be normally offset 1 foot of the 15-foot pipe to allow the proper expansion of the Z should be constructed only with 45 degree elbows unless 2 of the 19-foot lengths or pipe are used in the offset. Mandatory anchor pilots. Anchor points are located always between the expansion loops of the director with the expansion and the loops on the first and second section of the outside of the pipe. The pump station is the launcher of the receiver of the assembly. One of the first section of the pump pipe downstream of the gate and the check valve of the pipeline on the first and second section of the pipe with both sides of the elbows change the direction of the pipeline, both horizontal and vertical. Any anchors must be located at the bottom of the hill by expansion loop with the hill, and thereby there must not be more than 15 sections of pipe hanging downhill from an anchor. Pipe support guys, but must be installed when required to ensure the joint alignment maintained with the pipe, the support with the guidelines being constructed with the pickets, sandbags, and other available materials. Sandbags used should also be stacked in a pyramid to provide support during piping the movement. Never to stack one on top of the other. The pickets are used to keep the pipeline from slipping downhill when laid along the slope. There are 225 pickets and 2,000 sandbags in each 5-mile obstacles crossing, including road crossing, equal existing culverts when possible. Make sure the cross a section. You make sure that the cross is sectional. Road crossing. Use existing culverts whenever possible. Make sure that the crossing sectional area with the culvert is not significantly reduced, as this may prevent the restrict of the runoff water. 80 linear feet, 82-foot halves, 24-foot inch diameter decibel corrugated steel culvert are included within each 5-mile pipe set. Critical gap crossing kit to aid crossing gaps along the trace of the difficult terrain with a special critical gap crossing kit has been developed and added to the inland petroleum dispensing system operational stock. The two kits of the 400-inch steel pipe, cross beams, braces, and roller assemblies. Steel pipe can be cut and welded to any length required. A kit has enough material to cross up 250-foot gap. Part D, pump station operation. Pump stations are located along the pipeline to boost the pressure of the fuel. Maintaining the adequate pressure is must. With adequate pressure, the flow of the fuel would decrease to the point with little or no fuel would reach the head of the terminal. Information source of the pumping order. All users of military fuel in the theater are required to forecast their fuel requirements. They are consolidated at all levels, giving the theater fuel activity estimated with the fuel requirements at each time. Terminal pipeline dispatcher uses the information to schedule the fuel flow into each of the terminal, ensure that enough fuel is in hand to meet the expected demand. The dispatcher sets up a schedule includes the type of the quantity of the fuel and flow rate with the batch number assigned to the fuel shipment. The batch number is designated given to each of the fuel shipment. Most of the common ways of assigning the batch number of the fuel shipment, just assigning the number of the type of the fuel. For example, the 1 MoGas, 2 the diesel fuel, 3 JP4. The second number was the number of the shipment of the type of the fuel that has been shipped at the first year. For example, the first shipment is 1 2D shipment equals 2 by batch 1-2014 would be the 14th shipment of MoGas. One of the dispatcher has set up the schedule of the pumping order is made by each of the day and sent to all pipeline areas. Daily pumping order. The dispatcher issues the daily pumping order to the pumping station terminal operator. The pumping orders include type of the fuel, batch number, destination of each of the last amount of the fuel in batch, estimated size of the interface, estimated times of the arrival interface of the terminal, starting stopping times of all operation, type of the interface to cut pipeline pump station, pressures and pipeline flow rates. Part E, site selection and planning. When conducting a site route reconnaissance, you must have two known points where the fuel source will be located, where the forces will be located requiring the support. Site and the route selection. The survey using the topographical map must be conducted with the profile. Best trace the method made use the profile. Hydraulic limitation of the pump, marking the pump line, pipeline tracing. Required location of the pumping station. Conducting the physical reconnaissance on foot or by vehicle stakes. Other making the devices may be used to indicate the actual path of the pipeline, location of the valve, the anchors, expansion, contraction device. Any of the obstacles must be marked on the trace. Actual pump station location can be adjusted some over the ideal location selected with the profile hydraulic analysis, but every effort should be made to locate the pump station within 2,000 feet of the ideal locations. Plot plan. After the site has been selected, but the primary plot plan should be made with that show that all the major equipment of the system locations. After the plan has been reviewed, the correction made roadway and the berm construction can be made according with the plan. Pump station in a space of 140 feet by 85 feet is ideal, especially as the pumps must be positioned for access in case if one needs to be replaced during the operation. The requirement is at least 50 foot to the rear of the pump should be 10 foot off the road of the state anticipated with the location inlet and outlet pipe with the 95 at the edge of the road with 140 foot between stakes to align with the incoming and the outgoing pipeline. Tanker farm should be located to provide the wide space between the fuel and timid units and provide fire protection and suppression. Tank farm assemblies within the fuel unit should be at least 400 feet. There should be a minimum of 600 feet between fuel units. Fuel dispensing assembly. Fuel dispensing assembly should be located with the road capable of supporting heavy vehicle traffic during the weather changes. At least 100 feet from the nearest fabric tank. The plot plan requirement of the FDA at approximately 700 feet long by 50 feet wide in an area alongside with 120 feet by 80. 150 feet long should be created with the vertical for vehicle traffic parking while with loading. Tanker truck reciprocal receipt manifold. The most important factor in choosing the site Exact site in the road access since the heavy track will occur when the area of the tactical petroleum terminal, a great area on the 120 feet wide by the 250 feet long, is required per receipt manifold. Part F, external identification. Each of the ISO containers is marked with a large black border symbol. The pipeline components are represented by the circle. The tactical petroleum tactical petroleum terminal is the triangle. Each of the container has identification information stenciled on it. It is marked as part of the series. For example, the box 1 of 5. The pump station is marked by a diamond note. The packing is secured by the outside of each of the box or crate. Part G, communication. Each of the efficient communication system is much of the construction operation maintenance for the military pipeline. The system must be separate, continuous, dispensable, and ideally, chiefly the dispatcher will have the direct communication to each of the pump station operator to each of the tactical petroleum terminal. Each unit will set up their own communication system along with the pipeline with their capability teletype writers, field phone, radios. For example, no operation will start until there is communication between the issuing and receiving station. Pipeline petroleum will carry out the radios at all times, establishing hand signals with the effective form of the communication with the small sections such as pump stations, tank farms, and all personnel within the communication networks must be familiar with all the requirements that could be placed on them, what action must be taken in each situation. Alright, Lesson 3, compute berm requirements. Firewalls are designed to contain 100% of the volume of the storage tank plus 1 foot of the freeboard. The walls are intended to contain the fuel slip within the tank links overflow of the burst to help to prevent the spread of the fuel to the vapor. The new tanks or other insulation of the block instruction is designed to further your training so you can better supervise your personnel and terminal operations. Firewall should contain 100% of the capacity of the storage tank plus 1 foot freeboard. In the case of each of the firewall, they should be at least 18 inches wide at the top. The exact height of the firewall depending on the amount of the real estate or space available in the area in which the operating in a theater of operation is not uncommon to have a splinter and walls and a brick or concrete 8 by 10 foot high around the tanks that they serve as the firewall's protection against such things as low trajectory fire and blast, and sump will be provided with the lowest pump inside with the firewall. The rest of the air will be graded and drained to the sump. The sump will contain the outside of the firewall by drain line with the elbow swing point leg on the outside of the drain water from the sump, and the drain is closed by elevating the swing joint. Alright, this shows the berm of the firewall. Alright, Part B, formulas. Tank size and berm dimension requirements. The tank's capacity of the gallons, firearm dimension, feet, and the inner dimensions. 10,000 3 feet high, 5.5 foot wide by 26 by 26. 20,000 4 feet high, 1.5 foot wide by 31 by 35 foot. 50,000 4 foot high, 1.5 by 73 by 33. 210,000 5 foot high, 1 foot wide, 6 foot wide at the bottom by 73. The formula determining the inside of the diameter of the firewall is D, the diameter of the firewall, unknown feet, by the 2.68 times the square root of the tank capacity, known barrels, divided by the height of the firewall minus 1. We must construct the 6 foot beam around the 3,000 barrel tank. Diameter is 2.6 by 8 times the square root of 3,000 6 minus 1. You get the distance of a diameter of the firewall, 66 feet. The formula determining the height of the firewall based on the diameter is the H equals C plus 1, the diameter divided by 2.68 equal times 2. The capacity of storage tank at 3,000, the diameter is 6.57. You have a height of 6 feet. Another important factor considered with the construction of berm is the amount of the soil required, and figure the 3.2 the general dimension that must be considered with using the formula below. 3.3 and 3.2 identify the specific dimension for the given tank size. The formula determining the amount of soil required for the particular size berm is V equals AX and A equals W plus B times H2. V equals W plus BH times L2. V cubic yards is V is 27. The amount of soil required for the berm around the 3,000 gallon tank. Alright, you have your height, width, and berm, and width and length in the area. With the volume is 3 plus 1 plus times 3 times 12.6. Generally, the dimension volume for the soil quantity is 25. A soil quantity of 2, 25.2 square yards. This shows the tank size, filled area, the difference between the in between the berms and. All right, lesson 4. Recommended placement of the terminal equipment. A petroleum manager will be required to oversee the minor repair of the terminal equipment. It is in the best interest to know the proper procedure for reference material available to you. You will also be responsible for managing on-the-job training with the newly assigned personnel. The more knowledgeable you are in the area of the equipment to repair, the more effective your training program will be. You will also be responsible for the knowledge of the manifold system with the petroleum terminal on the unit. The bulk of the petroleum product the issue with the consumption for the terminal. They must be first received and stored in storage facilities where their capacity. All the facilities have the common feature that allows the control of the products entering, leaving, and transferring within the system. The control of the feature is the manifold. Part A, type of the piping and the couplings with the lightweight steel tubing. Lightweight steel tubing is limited with the gauge steel with the API standard 5L pipe. The nipples are welded to each end of the tubing is furnished within 20-foot sections of 4, 6, and 8 and 12-inch nominal size. Lightweight steel tubing is normally used for long stretches of the cross-country pipeline due to the greatly easy handling because under the condition it would experience only normal operating pressure due to its thin wall. The pipe is not to be buried, nor is it to be crossed by submerged streams across it. API standard API S&D 5L pipe. API S&D 5L pipe has a thicker wall than the lightweight steel tubing. The pipe is furnished with the 4, 6, 8, and 12 to 16 and 20-inch nominal side. The furnished with the 20-foot section groove with the coupling to be able with the welding the animal lengths is with the critical points for the high pressure areas such as downhill slopes and manifold areas and pump joints. For vertical couplings are used to join lightweight steel tubing with the API S&D FL pipe section together. Vertical is traded with the name associated with the coupling, which consists of two high hosing segments of the two bolts and nuts and a synthetic rubber oil resistant self-sealing gasket. The coupler and the gasket are designed so the pipeline joint seal is under the pressure of the vacuum. The coupling is provided with a sufficient amount of the angular deflection, slack adjustment of the expansion contraction of the line between the adjacent joints of the gasket. Used the coupling should be greased to prevent the pinching and sticking of the gasket. Aluminum piping is a new type of the pipe that's being evaluated for the future using the line in the Army. It is lightweight yet means the static and dynamic pressure requirements of the fuel system. The pipe has fewer of the corrosion problems and is available for the 9.5-foot sections used for the location similar to the lightweight steel tubing. The API standard 5L pipe with a high pressure situation are corrected in by use of the pressure reduction stations. Hinge snap joint coupling. The hinge snap joint coupling is standard for the single groove of the aluminum pipe with the two pieces of integral gasket coupling consisting of the two sections that are hinged together with the pin closing of the coupler of the over the pipe ends. The coupling gaskets are designed to seal under the pressure of the vacuum hinge to the coupling, allowing the 2% deflection between the joints and maximum allowable pressure working pressure MAWP of 740 psi. Cutting and grooving procedure with the steel pipe. The groove pipe is used with the coupling with the pipe. The section together with a split ring with the groove tap of the coupling due to layout. The damage of the section of the pipeline must be cut on a standard length of the re-groove to allow with the proper assembly of portable cutting of the grooving of the living machine is used to perform the task of the machine. The package with the kit are included with the welded pipe with the construction tool kit. Tool set with the kit included with a large suitcase with the two pipe that stands with the machine is poured with by the 250 cubic foot per minute with the air compressor by a generator. They can also be operated with the 24-volt system with the tactical vehicle is used with the primary during the pipeline pumping stage. In construction, it takes about 30 minutes to cut and groove each end of the pipe. Welding a pipeline. Pipe to be welded with the beveled edge of the facility, making the groove good weld. Rebelving because of the damage of the edge. The cutting of the beveling are accomplished with the machine described above. The beveling is cleaned or slag with the bevel grinding machine. Part B, gate valves. Gate valves have the gate in form of the disc wedge with the straight to permit the flow of the fuel below through the train. Stop the flow of the fuel. Rising stem of the gates. The rising stem of the gates are threaded with the upper end of the stem. The lower end of it is attached with the disc of the hand wheel that is turned with the bolts of the stem. The disc are raised with the lower. The valve is open full. It will allow the pipeline to scrape at the poly pigs and etc. to pass through. By looking at the valve for the distance, you can tell whether they're not a valve is open and closed. The stem, the valve is easy to sabotage. Exposed surface of the upper stem of the rising stem of the gate valve should be protected with placing a split or one each hose or some similar device around the stem in the yoke area. A fine film with the motor oil can be used to lubricate the thread on the stem. This valve is used for the pipe intervals with the bottom of the long slope on both the sides of the stream crossing it in storage tanks. Non-rising stem gate valve. The threaded lower end of the stem of the non-rising stem gate valve screws in the disc. It is thereby raising a lower disc while the stem is retained in the replaced by the thrust collar. This packing gland must be monitored and replaced by as necessary. Global valves. The global valves use the throttle to flow of the product inside of the pipeline. This is the same as the valve that you use in the home on the kitchen, bathroom sinks, packing, and the disc and the seats will become worn and they will be replaced. Depending on the usage, these valves are used in areas where the throttling of the product and flow is desired. Check valves permit the fuel to flow one way. The means with the hinge disc and the clappers, which with the push this out with the fuel with the flow the desired direction. The flow stops, then backs up. The depression develops, and the clapper is pushed against its seat and stops the backflow. The valves are set with the operating need little maintenance other than tightening of the cover. The nuts regularly. Typically, they are used on the discharge side of the pump and the pump stations. But the suction and discharge line with each of the pump at the pumping station, they also are used with the foot of the upgrade slopes and the loop of the gate valves. They must be removed if their line is ever pumped in reverse. Flow control valves, pressure reducing valve. The flow control valves are activated with the pressure. The pressure of the pilot system great enough to overcome the force of the spring of the excessive pressure activates the diaphragm to throttle the flow in the dynamic situation and static condition with the decrease of the head with the acting against the particular point of the pipeline with the valves is required with the maintenance beyond with the checking of the pilot strainer at least every 3 months and inspecting the diaphragm with once a year that they are used in the downhill slope. Pressure valve, relief valve. The pressure relief valves are set with the open with a certain pressure valve the trigger with the spring of the pipeline is tapped at the joint at the points with the experience of the excessive pressure under the static condition, the pressure of the reach of the upper limit on the set valve of the operative. The valve activates the opening of the bleeding of the fuel off the safe pressure and are again reached for the valve with the reset itself to the closed position. Typically, these valves are used the location where the pipe is going to a storage tank to bleed off the excess of the pressure but in the line because of the heating by the sun under the shut down conditions. These valves should be tested once a year using a reliable pressure gauge. Plug valves. Plug valves are small, the compact of the valves activated with the turning of the head of the valve 1/4 turn. The valve may or may not open with the full diameter of the pipe depending on the type of the plug valve. As a result, the plug valves which do not open to the full diameter of the pipe cannot be used in the portion of the pipeline through which the scraper is designed to pass. The valve can be lubricated and opened and closed at the position. Lubricating is done through the lubrication screw by the top of by the use of the high pressure grease gun, and the screw can be screwed down. The valve also has a rope tight packing which makes it periodically replaced in plug valves that commonly used with the tanker farm manifolds in place of requiring quick positive shut-off such as a scraper launching station. Additional pipeline components with line strainer. Line strainers catch the debris in the fuel and comes down into the basket. Strainer then passes through the discharge side of the basket. Has a high wire mesh screen which catches the debris, preventing the continuing flow of the damage. Downstream damaging things like the pump, the intermediate impeller blades, of the meters. The basket screens need to be pulled in the devices in which they are installed with a periodic schedule to remove the debris once a week. Lining strainers are found on the suction side of the pump and the meters on the discharge side of the filter separators. Part C, fittings and pipe repair accessories. Fittings, standard groove type. The fittings are included with elbow tees and reducers such as the following. Standard T fittings. Standard T fittings is provided with splitting in the fuel system. These fittings have the characteristic T shape. Reducing T fittings. Reducing T fittings allow reduction of one leg of the branch either through the T portion or through the branch portion of the T. Elbow fittings provide with the change of the pipeline direction of 90 or 45 degree. And reducers provide a connection from one diameter of the pipe to a smaller diameter of the pipe. Repair clamps list below the some of the more common types of the clamps used to repair the leaking in the pipes. Pit leak clamps. Pit leak clamps are designed temporarily to repair a leak caused by a small hole, such as a pit. Split leak clamps. Split leak clamps are designed temporarily to repair a leak caused by the split pipe. The clamp is limited in size of the split, which can be repaired to do the size its limited length. Overcoupling leak clamps. The leak clamps. Overcoupling leak clamps are designed to placement over the regular split ring of the groove type of the coupling when a leak develops with the initial coupling. A pipeline leakage report will be completed for all leaks occurring in the pipeline. Part D, pumps. Pipeline pumps consist of one or more of the impellers mounted on a rapidly rotating shaft. Liquid enters the impeller as in the center of the impelled outward with the central fuels, or as in the volate pumping case. The volate catches the discharge, converts the peripheral velocity into the head pressure while conducting the liquid at a reducing flow rate of the discharge nozzle of the pumping case. The different pumps are used on aluminum and steel pipeline systems. 6-inch single-stage pump. The 6-inch single-stage pump is a self-priming centrifugal pump equipped with a mechanical shaft seal, suction discharge connections, a groove pipe, the making safe working pressure at 207 psi at 660 feet of head for fuel with a special gravity of 0.725. 6-inch two-stage pump. The 6-inch two-stage pump is a multiple-stage pump fitted for the external connection to operate with either within the series of the parallel maximum safe working pressure of 700 psi or 2,390 feet of head for a fuel with special gravity of 0.725. 800 gallon per minute mainline pump. The 800 gallon mainline pump is newly pump used for the operation of an aluminum pipe link system. It is a skid mounted with the 3-stage centrifugal pump. Part E. This pipeline scraper and operation scraper the device inserted with the pipeline line to remove the internal scrape of the scale, rust, and the other foreign material. In petroleum industry, scrapers are often called pigs or go devils. Two types of scrapers are used with the steel brush scraper. The steel brush scraper is constructed with a tubular shaft on which they are mounted with the two sections of the floor spring-loaded steel brushes, the two synthetic rubber cups. The spring-loaded steel with the brush is clean with the wall of the pipe. The front of the rear of the brush groups the staggered to cover the entire of the pipe surface. The tubular shaft of the scraper is open at the rear of which permits the fraction to stream into the flow of the scraper escape through the small ports near the front of thereby aggregation of the propelling loosened scale forward that prevents the scale from accumulating head of the scraper and causing the line to be clogged. And the type of the scrapers come in 6 to 8 inch, 10 and 14 inch sizes. The 10 and 14 inch scrapers have three synthetic rubber caps. Alright, your polypig scraper device. The polypig scraper device is constructed with the foam type of the material wrapped with abrasive to clean the pipe. They are able to make the 90-degree turns in the pipeline and are inexpensive. They do not clean as the steel brush scrapers nor are they as durable. Military pumps manifold the two scraper stations, one of the launching and another within the receiving. Before the launching of the scraper line should be free from the sharp bends and valves. They do not open with the full diameter of the pipe to provide the free passage of the scraper. Change of the pipeline direction are made with the bending of the pipe rather than using the elbow or the T-fittings. Sand traps are in effect with the sediment and settling chambers, which collect dirt and scale and sludge and floating debris. The pipe thoroughly with the pipeline accumulated during the pipeline cleaning of the air installed with the suction side of the pump station. Sand traps with the flow into the two 14-inch barrels to reduce the velocity of the flow, and this also sediments to settle out. They must be cleaned periodically after each of the scraper run. Part F, manifold design factors. The following factors are affected with the theater support requirements: number of the quantity of the product, number of the quantity of the product depending on the theater needs, for example, the troops and equipment, number of tanks, the number of tanks depending on the quantity and the type of the product is stored, and the facility size, a minimum of 2 tanks per product, and preferred the number of the incoming lines with the number of the incoming lines entering the facility determined with the support location, number of the outgoing lines, and the number of the lines leaving the facility is determined by the location supported. Future expansion based on the expansion of the theater and an increase of the corresponding support requirements. The location of the facility is given with the manifold centrally located within it. Layout requires whether the manifold is located with the low point near the center of the tank of the farm piping network. The minimum distance to any of the tanks should be 250 feet. The construction of the manifold consists of the API standard pipe with the section pump lug valve of the API pipe with the accommodated with the high pressure associated with the sharp angles close proximity of the fuel source with the plug valves provided controlling and switching products as they require only 1/4 turn or open and close the valve. Manifold design. A manifold design is to support the facility which is located. The basic manifold is used in the facility is called the switching manifold, which is an assembly of the pipeline fittings and the valve used to control the flow of the petroleum products in and out of the within a tanker farm complex. The manifold located with the lowest part of within the facilities to ensure the positive suction to a transfer feeder pump. The manifold connects the number of the tanks within the incoming outgoing lines as well as the pump is used to transfer product. Single tank of the connected with the pipeline does not provide the flexibility to accomplish more than a single function. Multiple tanks connected to the pipeline, even with providing the increase in the capacity, can only perform the single function of the manifold. Symptom permits to simultaneously receive the delivery of petroleum products by the facility by adding a pipe fitting the valves. Control the product through the complete multiple tasks can be accomplished. Products can be received into one tank while issuing can continue simultaneously. Manifold identification marks. The identification system is essential for the control of the facility. The facility commander will establish the identification system where one is not the establisher or if a current system needs to be changed. The identification system should be kept simple. The system should be identify the tank of the pump line, the valve, and a systematic of the facility tank of the pumps and lines of valves, identifying each of the needs available within the facility for the reference systematic facility marking their suggested method of identification of the system. Whatever method is utilized by the actual facility schematic must be matched with the actual place in the following identification method is suggested. Valves are located along with the main line, are identified with the office of the chief of the dispatcher, starting with the beginning with the pipeline, ending the outside of the last of the facility head terminal. The valves are identified with the marking with the letter ML for main line valve with a dash and a number. For example, the ML1 denotes the valve as being the first in the pipeline series. The tanks are identified by numbers when the number of the tank valves are start with the first valve at the tank of the number that crosses the manifold. The sequence with the tank of the number down first valve by a dash in the tank valve number. For example, they identify with the tank number 10. All valves starting from the tank would be numbered subsequently, beginning 10-1, 10-2, 10-3, and so on. The last volume of the manifold for a particular line. Pumps and identified with the numbers. Pumps or valves may identify with a letter or number. For system, for example, the pump 1 can be suction and discharge valve identified with the individually errors in sequence. For example, P1 for the pump suction valve, PSV or P2 or pump discharge valve. The PDV2 or alternate has been identified valve the specific pump P1, P11, PSV 11, P12, PDV 12 for the pumping, suction, and discharge valves. Pipelines, both incoming and outgoing manifolds are identified by the letter when incoming lines of the pipeline begin with the enter the facility, ending with where the connect to the manifold. For example, the line entering the facility is identified with the letter starting with the A. Valves located with the line are indicated with the line followed by the dash, and then the numerical situation starting with the highest number that identifies the valve of the line just prior to the connection to the manifold. If the line has 55 valves in it, they would be numbered starting the A1, the valve nearest for the entry of the facility, ending with the A valve, the valve closest to the manifold, the outgoing lines being the furthest point outside and inside of the manifold, the outgoing lines being the furthest point inside the manifold are identified with a line, letter, and a dash and a number. The last valve in an outgoing line is one of the at the point where the line ends or exits the facility. Additional marking using in the system identification, including the following: direction of flow. The direction of flow and the lines indicated with an arrow physically placed and painted on the line. The directions can be it can be in one direction, only in both directions. Product identification of the product. The product identification for the product should relate to the product of the line. This tank line immediately outside of the manifold should show the product. Product identification for facilities. The product identification for facilities will be applied where practical, depending on the tactical situation for the commander's guidance. Lesson 5, Interpreting Pump Graphs.